going to look at one other factor that affects relationships in gases, one that is not pressure, not volume, not temperature, although this factor does affect pressure, volume, and temperature. So to do that, I have the same setup. I have a sample of air inside a container. I'm going to begin to heat it. As I heat it, we're going to talk about the changes that occur. Pull this back out just a little bit. There we go. The whole screen on. All right, so I'm going to begin to record, and we should see a line form again at around 100 kilopascals. In this case, it's going to be just a little bit less. Let me adjust that pressure maybe to get up to where I think it should be, right about 100. There we go. All right, so what I'm going to do is heat the flask again. We're going to take a look at the pressure. Once again, pressure is in kilopascals over here on the y-axis. So as the experiment proceeds, you'll see this line change. So here we go, we're going to heat it. We can see that the pressure is beginning to increase fairly quickly. Put it on auto scale again so that it's more dramatic. I don't want to take it much higher than 110 kilopascals because the stopper might pop out or it might melt my little piece of rubber tubing. Okay, so now I've taken the temperature away, the flame away. So the temperature is going to quit going up. As the temperature quits going up, now you notice on the y-axis, I haven't mentioned this, this is just time, it's how long I have the Bunsen burner underneath there, but I took the burner out, so the temperature is not changing, which means that the pressure is not changing. All right, now I'm going to make a change in the flask. I want you to see, just consider what I might be doing. Watch, here we go. Any ideas about what I might have done? Well, remember that little blue valve that was on the flask? What I did was open the blue valve, and when I opened the blue valve, air was able to escape. So the pressure dramatically decreased because molecules were moving out of the flask. I went ahead and sealed it back, and as I sealed it back, you notice the temperature is continuing to decrease. And as the temperature decreases, what I'm really doing now is creating a vacuum inside because the air is getting smaller and smaller. So it's not a complete vacuum, but it's a partial vacuum inside the flask. And so the air pressure outside is pushing the stopper in ever tighter. So it'll be more and more difficult to remove the stopper because the air that's inside is contracting and the air from the outside is trying to get in, so it's pushing the stopper in tighter. So the major point of this little video was to show you that you can also manage temperature and pressure by managing the number of molecules, which we call N. And we will take a look at that on pencil and paper at a later or a different video. I haven't made that one yet, but I will. All right, so once again, another variable is the number of molecules. In the first demos I did demonstrating Boyle's and Charles and Gay-Lussac, I didn't change the number of molecules, but in this one I did. And it's still just sitting there. You can see the pressure is continuing to decrease because I sealed it up. Now, if we wanted to explore what happens if I open it again. Let's get this, I'll open it and watch the right-hand corner of the screen. So when I opened it, air was able to go back in. And since the air went back in, we came back to our normal atmospheric pressure, which is about 101.3 kilopascals. And on this scale, I'm a little less than that. But that makes sense because in St. Louis, we're a little bit above sea level. Not a lot, but a little bit. So our pressure is going to be a little bit less because we don't have as much atmosphere above us. All right, so the last variable was the number of molecules.